Hey everyone, welcome back. We are diving into how C++ reads our math. When we write a mix of plus and minus and multiplication or division, we are creating what's called a compound expression. We need strict rules to figure out which one happens first. Like, is it a multiplication or addition, like the increment? Like, should we increment first or should we multiply first? And those rules are driven by two things, which are precedence and associativity. If you read this from left to right, it's gonna be 3 plus 4, which is 7, multiplied by 5, which would result in 35, but the answer is different. If we run the program, we are gonna see that the result was 23. Because of precedence, just like how we learned mathematics in elementary school, we first take the multiplication and then we increment by 3. What happens when the operators are at the same precedence level? Like in this example, most arithmetic operators in C++ are left-associative, which means that when the precedence is the same, they are gonna get grouped from left to right. First we group 20 minus 15, which would result in a 5, and then we decrement the 3, which would become 5 minus 3, 2. If it was right associative, it would become 15 minus 3, which is 12, and then we have 20 minus 12, which becomes 8, which is wrong. And here we have a more complex mix. So depending on how you guess the grouping, you would get different results. Like if you group first 6 plus 3, or 4 divided by 2, or 2 plus 2. When we run the program, we're gonna see that the result was 14. So the one with the highest precedence is 3 multiplied by 4. So it becomes like this. And then we have the division, because it's left associative, so we read it from left to right. So first we group both multiplication and division are equally in precedence, so we read them from left to right, and that's how the grouping would look like if we use parentheses. And then after this result, which becomes number 6, so it becomes like this, and then we group 6 plus 6, it becomes 12, and then plus 2, which is easy, like this. 6 plus 6 is 12, and then plus 2, 14. So all in all, this is how the compiler sees it. They first have some multiplication, and then the division, and then the plus 6, which is this parenthesis, and then we have the plus 2 at the end. And for you as a developer, you don't need to wait for the precedence to decide the result. So you can override them with parentheses. As you can see, you would get different results depending on how we parenthesize the numbers. So this one would read first 6 plus 3, which is 9, and then this one is 2, 2 plus 2, 4, and 9 multiplied by 4 is 36. This one will increment 6 plus 3, which is 9, 9 multiplied by 4 is 36, and then divided by 2, 18, and then plus 2, 20. This one would take first the 2 plus 2, which is 4, and then we read them again from left to right. 3 multiplied by 4, 12. 12 divided by 4 is 3, and 6 plus 3 is 9. Even if you know the default precedence rules perfectly, it's better to use parentheses because it makes your code more readable. So precedence decides which types of operators grab their numbers first, and associativity settles ties when operators are equal. And you can use parentheses to override this depending on what you want. If we have an array of integers and we declare the last element of that array, and we can use the pointer to the first element and move it 4 places, and then we can use the parentheses to dereference it. That way we are getting back the last element inside the array, which is number 8. So if we declare another variable and not use the parentheses, we just say the pointer dereferenced plus 4, and if we print the values, we can see that the correct approach actually returned the last value inside the array, and the second one didn't. Because of the dereference operator, the asterisk has higher precedence than the plus sign. So first what the compiler will do is it will dereference the first element inside the array, which is 0, and add 4 to it, which becomes 4. And one more example for the associativity is the stdcin and stdcout. Since they are both left-associative, the compiler will evaluate them from left to right. That's why when we enter the input first, we are storing it at v1. What is essentially happening is they are getting wrapped in parentheses, and after we enter the first number, it returns the cin stream object, and then the next expression would become stdcin, and then the extraction operator, and then v2, like this. Precedence doesn't tell us anything about the order of the function calls. If we have two functions that return a value, which is an integer in this case, and the multiplication operator needs to know the results before multiplication, in which order do you think the function calls would execute in? And we have absolutely no idea. The C++ standard leaves the evaluation order of operands for most operators entirely unspecified. The compiler gets to decide the order. It might call F1 first and then F2 if you are using GCC, or the opposite if you are using another compiler. And it is fine if these two functions don't rely on each other, but if they modify the same variable, you are basically playing Russian roulette. For my GCC compiler, it calls F1 first and then F2, and if I have an integer variable, which is I in this case, where in the same line we are printing the variable, we are also incrementing it. Since this operator doesn't have any guarantees on the sequence where these operands are evaluated, and this code triggers what is called undefined behavior. And undefined behavior means that the compiler will decide if I would get printed first or it would be incremented and then printed. Like it could print 1 1, or it could print 0 1, or it could crash or do something weird. And because of this, it is actually fundamentally broken no matter what your compiler is. So never do this unless you have a guaranteed sequence. And there are operators that have guaranteed order. First one is the logical AND, which guarantees that the left side would be evaluated first. So if the left side is false, it's not gonna look into this one. It's not gonna look at the right side. And we have the OR. It evaluates the left side first, and if it's true, it skips the right side. And we have the conditional operator. It's a one-line if-else statement. The condition is always evaluated first before deciding which path to take. And the comma operator, where it evaluates the left side first and it throws the result away and then evaluates the expression on the right. We can initialize an integer and set it to the minus value of another integer variable like this one, which would result in the value to be minus 1024. We can have a value that is true. When we assign it to another bool and add just the minus sign to it, it will still be true and they shouldn't be used for computation. And if I divide a value, if I have an integer variable and I wanna divide a number that has a remainder, so it's undivisible really, without becoming a decimal, the result is truncated and the remainder is discarded. So we'll get the closest result possible. In this example, we are dividing 21 by 6, so we will get 3. And same here, 21 divided by 7, we'll get also 3. But here there's no remainder. And we can use the percentage sign. We can calculate the remainder for the division between two numbers. So if we use the value 42 and add the percentage sign and then 12, what we are saying is that what would remain after dividing 42 by 12. So the closest answer, if we multiply 3 by 12, you'll get 36, and that's the closest number. We would add 6, because 6 plus 36 is 42. We cannot calculate the remainder between an integer and a double. And here are some calculations we can just look at quickly. What's the remainder of the division between 21 and 6? So 21 divided by 6. The closest number is 3. So if we multiply 3 by 6, we will get 18. And 18 plus 3, we are gonna get 21. And this one has no remainder because 3 multiplied by 7 is 21. And minus 21 divided by minus 8. We get the closest number is 2. So if we multiply 2 by minus 8, we'll get minus 16. And minus 16, if we add to it 5, so minus 16 minus 5. So minus 16 minus 5 equals 21, minus 21. And those are pretty much repetitive stuff. So I guess you get the idea. Overflow happens when a value is computed is outside the range of the type that it can represent. So this one, the maximum value it can store is 3 through 767. So if we add 1 to it, it will wrap around. So it will become a negative minus 3 to 768.